Hey guys, Miss Vasquez here, and today we're talking about adding and subtracting fractions with like denominators. We're going to follow the 5 steps, draw 2 rectangles, break those 2 rectangles into models, parts based on the denominator that's provided. We're going to shade the units to match our fractions, and then we're going to add or subtract the shaded units by shifting our pieces over. So let's go ahead and look at this first problem and see what we're going to do. So for the first step, it says to draw 2 rectangles. So I'm going to draw 2 rectangles because I'm going to represent these 2 numbers. The rectangles don't have to be perfect, but you're going to try and do as best you can. So in this case, I have 1/5, so I need to cut this in order to break up my models by the denominator into 5 pieces. So the denominator tells me how to cut my fraction up. So in this case, I'm going to cut it into 5. Okay. If you notice, this denominator is 5 as well, so I'm going to cut this one into 5. Now here's the great thing. If you have the same amount of pieces when you're solving a problem, this one has 5 pieces, this one has 5 pieces, you're dealing with the same size. The only way you can add or subtract fractions are if the parts are the same size. They have to be the same denominator for you to add and subtract. You can't do it if the parts aren't the same. So in order to represent this first fraction, I know I'm representing 1/5. So I'm going to color in 1 of 5. There we go. And then in order to represent the second fraction, I'm coloring in 2 of 5. So here's 1 and 2 of 5 have been colored in. Okay, so the number 4 tells me that I need to add or subtract the shaded units. So in this case, I'm going to be adding them together. To add them together, I'm actually going to create a box and add these fraction pieces together. So my box should have the same denominator as the fractions in my problem. And what I'm going to do is I'm going to take this one shaded pink over here, and I'm going to put it into my new box. I'm going to shift my piece over. Okay, and once I've done that, I'm going to take these 2, 1, 2, over here, and I'm going to add them to this new box. So I should have 2 green ones when I'm done. 1, 2. So once I'm done that, all I have to do is count what I have in my new box, and that's going to give me the answer to my addition problem. So in this case, I have 1, 2, 3 shaded out of 1, 2, 3, 4, 5. So my answer to my problem is 3/5. You do not change the denominator. You do not change the size of the pieces. The only thing you're allowed to change is the numerator, what you have. So I had 1 piece of the 5 pieces I needed. Someone gave me 2 more of the 5 pieces I needed. So now I have 3 of 5 pieces that I need to make a whole. So let's go ahead and see what this looks like for a word problem. Harper collected 5/9 of a bag of blueberries. His cousin gave him 4/9 of a bag of blueberries since he doesn't eat them and didn't want them to go to waste. What is the amount of the bag of blueberries that Harper has? So he had 5/9, and then his cousin gave him 4/9. Well, I know if his cousin's giving him, then he's adding to the amount he has. So this is going to be an addition problem. I'm trying to find the total that he has now. Okay, so if I wanted to solve this problem, I know the first thing I'm going to do is draw my 2 rectangles. Okay. So when you're drawing, you need to make sure that you have the right amount of cuts in your box. So you're going to count your box. So in this case, I need 9 pieces within my box. Well, I have 1, 2, 3, 4, 5, 6, 7, 8. Oh no, I'm 1 short. All you have to do is add 1 more sliver to your box. So even if you mess up and you don't add enough, it's okay. You can always add another sliver to your box at the end. Okay, so now I'm going to do the second box. Okay. So even though these are different sizes, we're going to count my box. As long as there's 9 pieces, it's okay. What is important is the amount of pieces in the boxes, not necessarily that all the pieces are looking exactly alike. We know that they're supposed to be equal, but we're drawing these, so we're going to be realistic. So I know I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I still have 9 pieces. So I'm going to represent 5 out of 9 pieces for this first one, and I'm going to represent 4 out of 9 pieces for this second one. So the first one, I need to color 5 of 9 of the pieces, and I'm going to use pink. 1, 2, 3, 4, 5 of 9. It doesn't have to be perfect, as long as you can tell what fraction it is. This one needs to be 4 out of 9. 1, 2, 3, 4. Oh, I made a mistake. It's okay. All you're gonna do is darken that line a little bit to show that it's not part of it. You're not gonna count that one, okay? It happens. Mistakes happen. As long as you recognize that doesn't count. You could even put an X on it so you know we're not counting that sliver, okay? I'm only counting 1, 2, 3, 4 slivers in this box, okay? So I actually need to bring in another sheet of paper to be able to show you this last piece, because now I have to consolidate these into one box. So I'm going to go ahead and bring my paper and cut my box. Wow, I did really well that time, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. Okay, so the first thing I'm going to do is I'm going to take these 5 pieces over here and I'm going to transfer them into my graph. So I should have 5 pink pieces. 1, 2, 3, 4, 5. Okay, and then I'm going to look over here and I'm going to say, okay, well, I have 4 green pieces over here. So I'm going to take 4 of these green pieces and I'm going to transfer them into my graph. 1, 2, 3, 4. Okay, so when I look at my little picture, my little table, I keep calling it a graph, I'm going to see that I have all of the boxes shaded now once I've brought them together. So when I have all the boxes shaded, if you look at the directions and the steps, if you can fill all the parts of a box, you count it as a whole. So I have 9 out of the 9 pieces I need in order to make a whole. Okay, remember when I told you that this bar means division? 9 divided by 9, 9 goes into 9 one time. It's a division problem waiting to happen. So I know that I have one whole box colored in. So let's go ahead and flip this to the back and do our next problem. So this next one, if we notice, we have a subtraction problem. Ooh. So we're going to do the same thing when it comes to subtraction. First, we're going to draw our box. Okay, we're going to subtract this time, so I'm going to put a subtraction symbol. I'm going to draw my next box. Okay, I know that I need to cut this into 4 pieces. It doesn't have to be the same as you normally would see it from the last time. I can cut it into 4 pieces this way, or I could do it cutting down. I know that 4 pieces is 4 pieces. Okay, so when I have 4 pieces, this one is 4 pieces as well. Okay, what do you think I'm going to color into this first box? How many of the boxes am I going to color to represent 3/4? Okay, so to represent 3/4, I look at my numerator. My numerator is 3, so I need to color in 3 out of 4. 1, 2, 3. Okay, to represent my second one, what am I going to color in? How many of those boxes am I going to color? To represent my second, I'm going to look at the numerator. The numerator is 2. So that means I'm going to color in 2 of 4. So I'm going to color in 1, 2. 2 of 4 have been colored in. Okay. Subtraction is a little bit different from addition in that I'm taking this and I'm subtracting this from it. So I'm not actually going to create another box. I'm going to keep this box. When I keep this box, what I'm going to say is, okay, I have 2 pieces that I need to X out from this box. So I'm going to X out 2 pieces. And then whatever is left without an X is what I have left. So in this case, I have 1 piece remaining. So my answer is 1 out of, and then the original box is made out of 1, 2, 3, 4. So I have 4. I have 1 out of 4 pieces remaining. So with subtraction, it's a little different. You're taking away whatever's in this amount of box from this. You could even, if you wanted to, color in the other color so you could see how it's taking it away. This one doesn't show up very well, but you get the point. Okay, let's go ahead and look at a word problem. Megan had 5/6 of a chocolate bar. Her mom ate 2/6 of her chocolate bar. Well, I know eating something makes it go away, so that's subtraction. So I'm going to represent 5/6 minus 2/6. And then we don't know what's left of her chocolate bar, so I'm going to put C for chocolate. That's making me hungry for one. So I'm going to first draw a box to represent my fractions. This is a subtraction problem, so I'm going to go ahead and put a subtraction symbol. Okay. I know that I have 5/6 in this first box, so I'm going to cut this box into how many? 5 or 6 pieces. Okay, so I'm going to cut this first box based on my denominator. My denominator is 6, so this needs to be cut into 6 pieces. Okay, the second box, the denominator is 6, so I'm going to cut this into 6 pieces. How many boxes am I going to color into this first to represent 5/6? If you did this correctly, you should have looked at the numerator. 5, 6, I would have to color in 5 out of 6 of the boxes. Okay, why don't you try this one? So if I did this one correctly, I know that my numerator is 2, so I need to color in 2 of the 6 boxes. Okay, now it's time to actually subtract. I'm going to take this and I'm going to subtract 2 pieces from it. This green might actually show up when I do this. So I know that I'm going to count 1, 2 pieces and I'm going to remove them, right? I told you you could also just color it in green and then you know it's gone. So she ate this piece and she ate this piece. So that's 1, 2. If you don't like it doing that because it kind of gets confusing, you might think, oh, I'm adding, then you can put X's to remind yourself it's gone. It's X'd out. It's no longer there. That might make it a little bit easier for your brain to deal with. So you can see all that you're left with is 1, 2, 3 boxes. Out of 4, 5, 6 boxes. Now really quickly I want you to look at that. So I have 3 boxes that are colored in, 3 boxes that are no longer there. That's 3 and 3. Well, 3 is half of 6. So really quickly I wanted to show you that you can find equivalent fractions by looking at what you have and what you need. So I have 3, which is half of what I need. So I have 1/2 of a chocolate bar. Okay. Another way to check and see if this is an equivalent fraction, let's say this was one of your answer choices and when you solved you got 3, 6. You can cross multiply. And when you do, you get 6 times 1 is 6. 2 times 3 is 6. And if, when you cross multiply, they call this the butterfly method because you can make a little butterfly out of it. Both of these numbers, when you cross them, equal 6. They both equal the same number, right? Then you know that these are equal or equivalent fractions. Okay. You're going to learn a little bit more about that when we talk about simplifying fractions and finding equivalent fractions later on. Okay, we're going to do our last problem, and that is our mixed number. So Peter had 3/8 of a pepperoni pizza. His mom had 7/8 of a cheese pizza. What amount of pizza does Peter and his mom have all together? So they both have 2 different types of pizza, but we just want to know in general, what is the amount of pizza all together, which means I'm finding the total. Because I'm finding the total and my parts are different, I'm going to be adding these together. Okay, so I get 1 3/8 plus 7/8 equals, let's say, P, the total number of pizza. So in order to represent this first one, I know I need 1 box to represent my whole, and I need another box to represent my part. So I'm going to draw 2 boxes. The first box represents my 1 whole, and then the second box represents my part. So I need 8 pieces because my denominator is 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 pieces here. And then I'm going to be adding that to another fraction that is cut into 8 pieces. Now remember, everything that I'm showing you today, the denominators have to be the same in order to do this. If the denominators aren't the same, you can't do this as easily as what I'm doing right now. So to represent 1 3/8, I know I'm going to color in 1 whole. So I just color in the whole box. Okay, with the next one, I'm representing 3 out of 8. So I'm going to color in 3 out of 8 of the boxes. Okay, on this last one, I'm coloring in 7 out of 8 of the boxes. Okay, so now that I've done that, I need to put them all together. So I need to bring them all together. So I'm going to go ahead and grab another sheet of paper because this does take a lot of paper, guys. Use as much paper as you need. The more paper you need, I will make sure that you always have it. Your parent will make sure you always have it. We rather you be accurate and be doing what you need to do. I'm not worried about wasting paper. Okay, so I know that I'm going to merge these two together into one answer. So I know that I have a hole here. Well, there's nothing that I can do with this hole. It's already full, so I'm just going to go ahead and I'm going to bring it straight down. And that shows me I have one hole. Color it in real quick. Oops, sorry. Ooh, it doesn't have to be perfect as long as you get the point. Okay, so now I'm going to draw a box to merge these two fractions. So I have to make sure that I have this cut into 8 pieces to match these two denominators of 8. Okay, once I do that, I'm going to pull 1, 2, 3. And I'm going to transfer those 3 pink ones down here. 1, 2, 3. Okay, so then I'm going to look at my green guys and I'm going to say I need to take 1, 2, 3, 4, 5, 6, 7 of these pieces and I'm going to bring them down here. 1, 2, 3, 4. Oh no, I only have 5 green pieces and I ran out of space. When you come to a problem where you do not have enough space to put all of those pieces, oh, I forgot a 4, sorry, 3, 4, 5. Okay, I'm missing 6 and 7. I still haven't placed 6 and 7. What's going to happen is you just need to create one more box with the same denominator. So I'm going to create another box of 8 pieces. Okay, once I've done that, I can go ahead and finish off what I was left off with. So I know that I've placed 5 of the green pieces, so I have 2 more green pieces left over that I'm going to transfer into this fraction bar. Okay. Now I have that 6 and 7. So if you want to check your work, all you have to do is make sure that 3 boxes here, okay, 3 pink boxes here, 7 pink or green boxes here, 7 green boxes here. So I've checked my work. So now I look at my problem and I see, well, what do I have? Because every single one of these are colored in, I know this is one hole. And then because only 2 out of 8 of these are colored in, I know that this is 2 8s. Okay, so when I'm looking at this, I need to put this all together. I see 2 holes. So my answer is I have 2 holes and then 2 out of 8 left over. When we talk about simplifying, this can be simplified. If you actually look at what you have here, and I were to cut this in half, I can see it's still not even. I still don't see equal pieces, but if I were to cut it long ways in half again, I see, oh look, here's 1 area, 2 areas, 3 areas, 4 areas. Out of the 4 areas, 1 of 4 is shaded. So I know this is equivalent to 2 1/4. Like I said, we'll talk about simplifying later. I just wanted to show you really quick. Another way would be to divide both of these by 2 because both of these are divisible by 2. Either way, as long as you can get to here, that's all I need you to be able to do for now. I will teach you the rest later, like I said. But I hope this was clear and understandable.